Welcome you all for the session of theory of compilation. Now we're going to see about regular expression to obtain a regular expression that denotes a language accepted by the DFA. So which means it is a conversion from DFA to a regular expression. So for this we will have this rules, identities of regular expression rules. So the rules are as follows. So whenever just refer these rules and you have the idea to convert from this DFA to a regular expression. So here these are the important rules. These are known as different identity rules of regular expression. Just refer these rules and you'll have this idea how to solve this, right? So for this problem, so we'll go to solve the conversion. Okay, so for this is the method of regular expression equation method. So this is solved by, so this is regular expression equation method, right? For this we'll have the formula, which means Rij of k equal to, it is a suffix, so Rij of k minus 1. So the formula will be Rij of k equal to Rij of k minus 1 plus Rik of k minus 1 Rkk of k minus 1, the whole closure, R kj of k minus 1. So the formula here is, so the formula, see this formula. So the formula here is Rij of k equal to Rij of k minus 1 plus Rik of k minus 1 into Rkk of k minus 1, the whole closure, and Rkj of k minus 1. So this is the way you have to use this formula for conversion from given DFA to a regular expression. So for this we'll have to get a result expression. So to find the result of the regular expression, to find the result of the regular expression, so we will have this, right? To find the result of the regular expression, we'll have this formula. So first we'll look at what are all the states over here. So how many states over here? So here 2 states is there. So for this, so here I equal to 1, j equal to 2, and total number of states is also 2. So the result will be find out by using, see here, the result of the regular expression is given by the result of the regular expression is given by R12 of, so why? Because I equal to 1 here, j equal to 2, and k is also 2, the total number of states. So here this is initial state, and j is a final state, and k is a total number of states. So now see here, so I is a initial state and j is a final state and k is equal to total number of states. To find the result of the regular expression, this is the first step. So the formula here, this is the number, step number 1. right? After that, we'll have to look at this, right? So R12 of 2 equal to the formula will be applied over here. So the formula here is, see here, so this formula should be applied in that place, right? Rij of k, Rij of 1 plus Rik of, so the k value is 2, right? 1, Rkk of 1, so that, which means these are all k minus 1, right? The whole closure, and Rkj, so k2 and j is also 2. So this is the way we have to look at it. So this is the result of the regular expression. So after that we will have this steps. So here R12 of 2 we have to find out. So whenever we want to see R12 of 2, so we have to find a different set of k values. Actually initially k equal to, so for this we have to substitute, let k equal to 0. So whenever we will keep the k equal to 0, we will solve this 1 to 1 transition. See this diagram. So here we will have this, right? So whenever k equal to 0, R11 of 0, R12 of 0 we'll have to find out. And R21 of 0 and R22 of 0. Okay. So whenever we will have this idea, so we will find out what is this functions. So by using this we will have right, so we will have this kind of diagram. So look at the diagram over here and see what is R11 of the self loop, R11 of 0. It is by default it is each and every state is having epsilon transition, so epsilon plus 1. So we have this epsilon plus 1 and R12 of 0, right? So by seeing this diagram, so R12 of 0, so it is 0, right? So R12 of 0 is 0, and R21 of 0, so there is no from 2 to 1 transition, so it is known as 5. And R22 of 0, so each and every diagram, each and every state has its own epsilon transition, so it is said to be epsilon plus 0 plus 1. Okay. Then, so this is known as k equal to 0. For k value, it is like this. Okay. After that, so after that we will have this. Let k equal to 1. For k equal to 1, we will have to apply the formula Rij of k equal to Rik of Rij of k minus 1 plus Rik of k minus 1 Rkk of k minus 1 closure and Rkj of k minus 1. So we will apply this. So R here I equal to 1 and j equal to, now we will see this, right? Similarly we have to find this value R11, R12, R21, R2. So now we will have I equal to 1 and j equal to 1 for this. So R11 of 1 will have to see. So why? Because initially we will take k equal to 0, now we will look at for k equal to 1. So again R11 of 0, so 5 means here it's a k minus 1 plus Rik. Ik in the sense I is 1 and k is also 1 over here, so 0. K ik and kk. What is kk here? 1 1 of 0 closure. kj, what is k? 1 and j is also 1, so we'll have this. So use this previous step result. So epsilon plus 1 plus epsilon plus 1, epsilon plus 1 the whole closure, and epsilon plus 1. When you take the out epsilon plus 1 from the two steps, when you take this part, epsilon plus the whole closure and epsilon plus 1. Okay. So for this epsilon plus 1, and this is the kind of epsilon plus r star r, which means you get an r star. So epsilon closure, r closure. So the formula here is epsilon plus r star r, which means r closure. So that's why here the r will be like this. So epsilon plus 1. So this is epsilon plus r the whole closure, which means r closure, which is 1 closure, right? So this is again epsilon plus r into r closure, which is r star, which is 1 star. See this? So epsilon plus r into r closure, which is equal to r closure, which means 1. So this is the way it has to be solved. So after that, r12 of 1. So we have to solve this r12 of 1. So how do you solve this? Write in formula for this. So r12 of, so here I equal to 1 and j is equal to 2, right? r12 of 0 equal to ij, ik, right? So what is ik? I is 1, k is also 1. For the step of 1, k equal to 1, we will solve this, right? So 1, 0, so r kk. So kk in a sense, so 1 1 of 0 the whole closure, and kj. So k value is 1 and j value is 2. So which means it. Okay, so now substitute the value. r12 of 0, what is r12 of 0? 0 plus 1 1 of 0, epsilon plus 1, here epsilon plus 1 the whole closure, and r12 of 0 whole 0. So when you take the 0 out, so when you take the common term, it will be epsilon plus 1 into epsilon plus 1 the whole closure, right? Okay. So now epsilon plus, so this is the formula of epsilon plus r star, r into r star. So we're having so the same formula apply here. So epsilon plus 1 the whole closure. So which means, so since it is epsilon plus r into r closure equal to r closure, and this formula is applied over here. After that we have this epsilon plus r. So this formula is epsilon plus r the whole closure equal to r closure. So which means, so this is 0 1 closure. So this is the way it is solved, right? Okay, fine. So for the next set of values, we'll have this. So next we'll see r. So we'll have only 2 sets, right? So what is the previous value we have found out? r11 of 2, r11 of 0, r12 of 0. So for this we'll similarly we have to find out r11 of 1, r12 of 1. After that we'll have second state, which means we'll have the transition of 2 1 of 0 and 2 2 of 0. Similarly we'll look at the value of k, r21 of k and r22 of. So see this how it will happen. So now we'll have to see this r21 of k. So again the k value will be 1. So now I equal to 2, j equal to 1, and k is a constant value, because here for the set of 1, k value equal to 1, we will find all these things, right? So k is also 1. So apply this formula, ij of 0 plus r I or ik. So 2 k is 1 0 kk. So k is 1 1 of 0 closure kj 1 and j is also 1. So we'll have this. Right. Okay. So r1 so we have substitute this value. So 2 1 of 0 plus this is also 5. After that r11 of 0 will have epsilon plus 1 the whole closure, and you will have again epsilon plus 1 the whole closure. Right. So whenever we will have this multiplication with a 5 value, so we already see this formula. When you multiply any regular expression with a 5 value, it is always gives a, so this one, it is always gives the 5 value. So fully converted as 5. So after the addition of plus 5 into 5 plus 5, you will get 5. Right. So this is the value for this. After that r22 of 1. So apply this. So here I equal to 2, j is also 2. So k is 1, right? Okay. So r ij of 0, r ik of 0, r kk of 0, and the whole closure r kj. K in the sense 1 and j is 2 of 0. So here look at this value. Of 0, what is the value? Epsilon plus. So epsilon plus 0 plus 1, right? Plus, and here here I value is 2, right? So I just mistakenly have written. So I value is 2, right? So 2. So r21 of 0. What is r21 of 0? 5. And after that, so here also 5 closure. And you're having 1 2 of 0, 0. Right. So anyway, we'll have this epsilon plus 0 plus 1. So whatever the value will multiply with this pi, it is always a pi value. So it is pi, right? So pi into any regular expression. Okay, fine. We'll have epsilon plus 0 plus 1. After that we'll look at the result. So why because we have found out, so r21, r22 and r11 and r12. So the result of the regular expression for our cases, so this is our result. So see here, result is r12 of 2 equal to r12 of 1. So the k value up to k value 1 we have to find out over here. So for this k value 1, we have found out these steps. So we'll stop this step. After finding k equal to 1, we'll stop this step and apply the result to the result of the regular expression. So here the result of the regular expression, right? So result of the regular expression. So take this result from there. So r12 of 2 equal to, just refer it, r12 of 1 plus r12 of 1 r22 of 1 the whole quotient and r22 R12 of 1. Okay, fine. So write R1. What is R12 of 1? R12 of 1 here 0 1 closure. This R12 of 1 again 0 1 closure. R22 of 1 epsilon plus 0 plus 1 the whole closure, and 22 of 1 here again epsilon plus 0 plus 1. Okay, so here the common so see this, so the common step over here, right? So we'll take the 0 1 closure out, so the common term is this one, so we will have epsilon plus 0 plus 1 the whole closure, and epsilon plus 0 plus 1, right? So this is the formula like epsilon plus r star r, which means you will get r star. So epsilon plus 0 plus 1 the whole closure. So this is the formula of, since we are having epsilon plus r star are equal to r star, right? Okay, 0 1 closure, and you have this epsilon plus r. So what is that? Epsilon plus r the whole closure. See, epsilon plus r the whole closure will have r closure. So 0 plus 1 the whole closure. So this is our final regular expression. So for this problem, for this kind of DFA, we will get this. Result will be R12 of 2 0 1 the whole closure, zero plus 1 0 1 closure, and 0 plus 1 the whole closure, right? So this is the way we will have solve this, right? Okay, fine. So see how this result will happen. And one more thing, so when you see this kind of thing, right? So when you have this diagram, this kind of diagram, so when you are having this kind of diagram, so see this, so when you are having two final state over here, if suppose something some kind of problem coming like this, means we will solve by using we have to find the same regular expression formula, but for this we are having two different states. So for this we will have to apply for the two final states, the result of the regular expression for this is R11 of 3 plus R12 of 3. So why? Because for this we will have to combine initial state and final state. For this you will have one is an initial state and one is a final state. For this you will have to calculate it, and again you will have one for Q2, one is an initial state and 2 is a final state. So for this we have to use this. So the result of the regular expression will be R11 of 3 plus R12 of 3. Okay, thank you.